And they're talking about your different rules again, so I could ask you to approach plus or minus infinity, the positive or the negative infinity. If the n is smaller, so in other words, the degree on the top is smaller, small over big goes to 0. If they're equal degree, then use the leading coefficients, all that stuff. There are a couple questions on the test that deal with sequential notation. So we're still going to work with a couple of sequences. And the point of it would be you could write down a couple of the first numbers and see probably what's happening from there. So let's just get, for these, let's do 5 numbers. So we're going to do, what do you get when n equals 1? 3 over, right? 3 times 1 is 3, 1 squared is 1, plus 1 is 2, so 3 over 2. What do you get when n is 2? 6 over 5. What do you get when n is 3? 9 over 10. What do you get when it's 4? And 5? So if you look at this thing, it starts out at 1.5, then moves to 1.2, then 0.9. So it actually, it's starting to come down, right? 12/17, by the time we get to 15 over 26, we're at about 0.5. So you can see this thing is starting to shrink. What eventually is it going to go to?
0.
Eventually, it's going to 0. How do I know that? This is a first degree over a second degree, which is, some of you might just write down small over big. We know that as the bottom of a fraction continues to get much larger than the top, it's going to go to 0. So, for practice with somebody sitting near you, please do part B here. Write out 5, the first 5 numbers of that sequence, and then identify what your limit is. Show the person sitting next to you what you have for an answer.
Wait, what? You didn't even write the first 5.
What were the first 5?
We have
3 over 12 over 5, 27 over 10, 48 over 7.8, 25 over 75 over 16.
Like that?
Yeah.
What was the point of us doing?
So 3 over 2 is 1.5. 12 over 5 is, what, 2.4? Then 2.7, so 48 over 17. Whatever. You're getting close to 3. Yeah?
Yeah,
Right?
sure, yeah.
Yeah. Alright. So the last one is, right? This is the last problem. This is what I would call an ACT type problem. And this is why. What they're trying to do is see if you guys truly understand the problem. If you truly understand the problem, you're going to save yourself a ton of work. Because a lot of people are going to come in here and they're going to go, oh, I need to go n plus 1 times n plus 1 and multiply that out, and then multiply by the n squared, and then multiply by the 6. But what am I really concerned about?
Agreed.
What I'm really concerned about, what is the very first term that will be on top, and what is the first term on the bottom? There can be all kinds of other stuff with it, but it's all about the leading term in both cases. On the bottom, if you just multiply the bottom here, we're looking at 4 n to the 4th. But if you multiply what's on top, again, you don't waste your time. What are you going to get for a first term here? N squared, right? Times another n squared would be n to the 4th times 6. I know there's other stuff there, but I'm not going to spend my time finding it because this is an infinite limit. I don't need all the other stuff. I just want to concentrate on that. And what does it tell you when that's 4th degree over 4th degree?
6 over 4.
Which is 3/2. So, on the exam, you need to pay attention. What are we asking you to approach? If we ask you to approach infinity or negative infinity, you still have to write something down as far as how you know what your limit is. And that would be like, write your degrees down so that you're identifying a big over small, small over big, or equal degrees. You can write big over small, small over big if you want. Okay? We're done. Yay!